In this video, we learn the basic definition of matrix and we'll define what is a rank of a matrix. Matrix, a system of mn numbers arranged in a rectangular form with m rows and n columns, and it is denoted by capital A, and the elements are denoted by the small letters, and it is read as m by n, and mathematically we'll write it as m by n. For example, let us consider a matrix of order. We'll write it as an order. Order is m by n, that is now it is 3 by 3. 3 rows and 3 columns. And B is a matrix, and here we have 3 rows and 2 columns, and it is read as 3 by 2 matrix. And here C is a matrix which has 1 row and 3 columns, then we'll denote it as 1 by 3 matrix of order 1 by 3. What is a row and column matrix here? A matrix with a single row is called as a row matrix. For example, if A is a matrix with a single row, now how many rows are there? 1 row, and how many columns are there? 1, 2, 3, 4. So it is a matrix of order 1 by 4. And a matrix is said to be a column matrix if it has a single column. For example, consider a matrix B, and you see that it has only 1 column and 3 rows. And now we'll denote it as number of rows are 3 and number of column are 1. Now we'll see what is a square matrix. A matrix in which the number of rows and the number of columns are equal, then the matrix is said to be a square matrix. For example, so A is a matrix now. You see that number of rows are 3 and number of columns are 3. Then we'll write it as order as 3 by 3, and we'll call as a square matrix of order 3. Now we'll define what is a diagonal matrix. A matrix in which the diagonal elements are non-zero elements and the remaining all elements are zeros, then it is said to be a diagonal matrix. For example, let us consider a matrix B, so which is of order 3 by 3, in which all the diagonal elements are non-zero and the remaining elements are zeros, then it is said to be a diagonal matrix. And in the special case, if you consider the diagonal elements as 1, 1, 1 and the remaining elements are 0, then the matrix is called as a unit matrix, and it is denoted as I. And if I consider the diagonal elements as, so all the diagonal elements are constant, so k sum k, 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 and the remaining elements are 0, then the matrix is called as a scalar matrix. Okay. Now we'll define what is a submatrix. A matrix is obtained by eliminating, deleting, or removing any row or column from the given matrix, then the matrix is said to be a submatrix here. For example, let us see a matrix A, and the matrix A is of order 3 rows and 4 columns. We'll write it as 3 by 4. Okay. Now if I remove the first row from this one, we'll get the remaining 2 rows and 4 columns, then it is said to be a submatrix of order. Now see that 2 rows and 4 columns, then it is a matrix of order 2 by 4. Now by deleting the 3 and 4 columns of a given matrix, we'll get a matrix of 2, 1, 6, minus 1, 1, 0, and its order is now defined as what? 3 rows and 2 columns here. Then it is called as a submatrix. As a result, so we can say that every matrix itself is called as a submatrix. Now we'll define what is a minor of a matrix. So the determinant of a square submatrix of a given matrix is called as a minor. Now if the order of the submatrix is R, then the minor is of order R. Now we'll see an example. So let us consider a matrix A of order 3 by 4. That means 3 rows and 4 columns here. We can see that 3 rows and 4 columns. Now we are going to form the minors of this matrix of order 3 by 4. So if I remove the first column, then we'll get a submatrix. This is a submatrix, and if you do its determinant, then it is called as a minor of order 3. And if I remove the second column, then we'll get the remaining elements 2, 6, 1, 3, 7, 5 and 4, minus 8, 3. This is a submatrix, and its determinant we'll call it as a minor. Now we'll see the minor of order 2 by eliminating the second and fourth column and next third row. So we'll get the elements as 2, 3, 6, 7. It is a submatrix of order 2, and if you do its determinant, then we'll get a minor of order 2 here. And similarly, by eliminating the remaining columns and rows, we'll get the minors of order 2. As a result, each element in the matrix, each element in the given matrix can be considered as a minor of order 1. And a matrix of order 3 by 4, it cannot be expressed as a minor of order 4. Now we'll define a rank of a matrix. A positive integer R is said to be the rank of a non-zero matrix of order m by n. If it satisfies the conditions here, it should has at least one non-zero minor of order R, and every minor of order higher than R must be 0. Then if it satisfies these two conditions, then it is said to be the rank of a matrix, and the rank of a matrix is denoted by row of A. Some important results based on the rank. If A and B are the similar matrices, then rank of A and rank of B are equal. If the rank of A and A transpose are always equal, the rank of a null matrix is always 0. The rank of a non-singular square matrix of order R is R. If A is a square matrix of order n, then if the rank of A is less than n, then it is said to be a singular matrix, that is det A equals to 0. If A is a matrix of order m by n, rectangular matrix, then the rank of A is always less than or equal to the minimum of m comma n. The rank of a identity matrix of order n is always n. Thank you.